Hi everyone, in this video we are going to practice ranking polar bonds. And so the first way we can do this, or the most important way you can do this, is by starting off by ranking electronegativity of the corresponding atoms. So let's start off with these three groupings here. So we have group A, B, and C. Each group has three different elements in it, and I want you to rank them from least to most electronegative. Go! Alright, did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing you should be able to do, or you should do if you're approaching a problem like this, is just map out your trends for electronegativity. So if I were to draw the periodic table in a box form, right, as all periodic tables look like, we would remember that our electronegativity increases as we go up a group, but it also increases as we go across a period. So instead of drawing just like up and over, what we usually draw is just one diagonal. And so we would say that right here in this upper right-hand corner, these are your most electronegative elements, which means in your opposite corner, so your bottom left-hand corner, these are your least electronegative atoms. Some people say instead of electronegative, they say electropositive, so both words are absolutely fine. So let's start off with group A. So what we need to do here is figure out where these elements reside in the periodic table. And so basically what we can see is that our bromine is going to be directly below our chlorine, but then we know that our aluminum is way further down the periodic table this way, okay, across the period. So if we were to rank our electronegativity, right away my eye is drawn to chlorine, because chlorine is one of the most electronegative atoms. It's not the most one, but it's the third most. So if we were to rank these, we would know that fluorine is our most electronegative, followed by oxygen, and then nitrogen and chlorine are actually tied for second place for electronegativity. So if we were to rank these out, right away I go to chlorine. So chlorine's going to be my most electronegative, followed right behind with bromine, because bromine's directly below it. Afterwards, we actually go to aluminum. And now a way for people to decide between bromine and aluminum, first things first, bromine's a halogen. If you're ever looking at a halogen, those are going to be electronegative atoms. They want those electrons so badly. But another thing is, aluminum would prefer to be a cation. Aluminum would prefer to be aluminum 3+ instead of something like aluminum 5-. Like, that is never going to happen. And so right away, you should be able to look at aluminum and be like, that wants to be positive, wants to be a cation, definitely not going to be electronegative, or highly electronegative. All right, let's move on to B. So now we're looking at B. We need to rank these elements across the periodic table. So the first thing I notice is strontium and barium. Now personally I know this because I know the periodic table, but you might not know it. You need to look up the periodic table and see that strontium is directly above barium. So right away I can tell you that strontium is going to be more electronegative than barium. But now we have to look at tellurium. Tellurium is actually ranked all the way over here, positioned all the way over here on the right side of the periodic table, where our strontium is in the same row as it, but over here on the left. And so right away we see that the tellurium is on the right side of the periodic table, definitely going to be more electronegative than strontium. Alright, so now we have one more group. Right away, you should be able to rank this one. Just boom. I want C to be such an instinct for you, and you need to get to the place where it is an instinct for you, where you can just innately answer this question. Because what I want you to do is see, oxygen, definitely more electronegative than chlorine, which is definitely more electronegative than carbon. If you can get to this point where you can automatically rank those three, then you should feel pretty good about this material. Alright, so let's move on. Ranking electronegativity is always step one for ranking bond polarity. After you can figure out which is the more electronegative atom, then you can usually see, is there a difference between electronegativity within that bond. So again, here we have three different groups. I want you to rank them from least to most polar. Go! Alright, did you get an answer? Hopefully you did, but if you didn't, that's okay. Do not get frustrated. So just for simplicity, I'm going to redraw this little teeny tiny electronegativity chart, and I'm going to remind ourselves that fluorine is more electronegative than oxygen, which is more electronegative than nitrogen and chlorine together, okay? So now what we're going to do is look at group A and try to rank these in terms of polarity. So we're going to go from least to most polar. So if we're starting off with least polar, the first thing you want to look for is a covalent bond, so just any type of bond like that, drawn like this, that has the same element on each side. And so right away I see a carbon-carbon bond. Right away you know if it is two elements that's the exact same thing, they are going to have the exact same electronegativity. There's no way for that carbon-carbon to be bond to be polar at all. That's not possible. So right away you should write C less than. It's going to be your least polar. Now then, the second thing my eye is drawn to is this fluorine. And so right over here we mentioned that fluorine is our most electronegative atom. So right away you should be like, oh my gosh, this CF bond is going to be incredibly polar. All of those electrons are going to be pulled from that carbon atom directly to that fluorine atom, and they're going to be attracted to that insanely positive fluorine nucleus. So your carbon-fluorine bond is definitely going to be the most polar, which leaves us with a carbon-hydrogen bond. Now, biologists will tell you that that is a non-polar bond. I hate that. It is definitely a polar bond, but it's slightly polar. It's teeny tiny polar. So the way I like to say is that carbon-carbon is definitely non-polar, carbon-hydrogen slightly polar, carbon-fluorine, that is a polar molecule. Definitely polar, but for this example, polar bond. Okay, so now we're going to group B. So now you're able to rank this one. Right away, you see our little trend right here. Fluorine, oxygen, nitrogen, it's in the proper order. Nitrogen is less electronegative than oxygen, which is less electronegative than fluorine. Now, we are having all three of these elements bonded to a single carbon atom, and so all we had to do for this exercise for group B was literally just rank the electronegativity of nitrogen, oxygen, and fluorine. So hopefully that was kind of an easy one for you. All right, so now let's move to group C. And what we see here are double bonds. Now, one of the biggest questions I get from my major students, okay, not my non-majors, my major students, is does the double bond change anything? Does that change electronegativity? And the answer is absolutely not. All it does is tell you that these two elements are sharing 4 or 6 electrons instead of just the plain old 2 with a single bond. All right, so what did we learn from our first two things? The first thing we look for is something that has the exact same element. So an oxygen or a diatomic oxygen molecule is definitely going to be our least polar. And then right away, I see one of our 3 most polar atoms, which is oxygen. So right away, I want to put this carbon-oxygen end all the way on the end as the most polar bond, which leaves us with a carbon-sulfur bond in between. And now if you want to check that, the best way to do that is to go over here on the periodic table, and you would see that you have nitrogen, oxygen, fluorine, and directly under your oxygen is your sulfur. So oxygen is definitely more electronegative than sulfur, so this is the correct bond order. All right, so now I'm going to kind of challenge you. Hopefully you understand electronegativity and you understand polarity. What I want you to do now is look at an actual molecule. So I've drawn this out. This is a very simple structure, and what I want you to do is look at these 3 bonds. So I have them labeled A, B, and C, and I want you to rank them from least to most polar. Go. All right, did you get an answer? Hopefully you did, but if you didn't, do not freak out. This is definitely one of the most challenging problems I've given you on this topic. The first thing you have to do is identify what these bonds actually are. So let's label them A, B, and C. So let's start here by looking at A. This A bond is just our hydrogen-nitrogen bond. So we can rewrite that here, H, and done. Now our B bond is right here. That is a carbon and a carbon. That is a double bond in the center. So a carbon-carbon double bond. And then C is the hardest one to identify, maybe. I mean, it depends on how you think about this. That point right there is definitely a carbon to a hydrogen. So C is a simple carbon-hydrogen bond. Now we're just ranking them from least to most polar. So just like before, what we start off we're looking for is a bond that is between 2 of the same element. So our carbon-carbon double bond is definitely going to be our least polar. Then we see our carbon-hydrogen bond, which we know is slightly polar, just barely, just teeny tiny polar, not much, so that goes next. And then after that is an NH bond, which we know is extraordinarily strong and a very, very good, or not strong, polar, that's the word I'm looking for, a very, very polar bond, because the nitrogen charge, that nucleus is so positively charged that it's pulling all of those electrons away from the hydrogen. So those are 3 quick problems to try to deal with polar bonds. Please carry on and go to that next video where we're going to talk about polar molecules. Have a great week. Take care of yourself and drink water.